let's take a look at this example. We have to find I1, okay, current which will go through resistor R1. We're supposed to find I2. We're supposed to find R2, okay, and we are going to also find R total. Also, we are going to find P total. We are going to find P1, P2. We are going to find P3. Okay, basically we'll try to find everything, whatever is possible. So now, please notice that current I2 is 3 times larger than I1. So it means that my resistor R2, okay, is 3 times smaller than resistor R1. So if the current in this resistor is 3 times greater than this current, it means that this resistance is 3 times smaller than this one. So I'm going to simply write that R2 is equal R1 divided by 3. R1 is equal 20 kilo ohms divided by 3. So I have 20 exponent 3 divided by 3. This is equal 6.67 kilo ohms. This is the resistance of resistor R2. Next, we're supposed to find the current I1 and I2. Okay, so when we have resistances, we have R1 and we have R2, we can use current divider rule. Okay, let's say we have current divider rule. So in order to use current divider rule, we're supposed to find total resistance first. R total is equal R1 times R2 over R1 plus R2, where R1 is equal 20 kilo ohms times R2, which is equal 6.67 kilo ohms divided by, and I have 20 kilo ohms plus 6.67 kilo ohms equals. So if R total equals. So we have 20 exponent 3 times 6.67 exponent 3 equals, divided by, open parenthesis, 20 exponent 3 plus 6.67 exponent 3, close parenthesis, equals 5 kilo ohms. Okay, my total resistance is equal 5 kilo ohms. Okay, now I can use current divider rule. So I have formula which says I1 is equal I total times R total over R1. Okay, so this is I1 equals I total. I total is equal 3.2 milliamps, so I have 3.2 milliamps times R total, which is equal 5 kilo ohms over R1, which has value of 20 kilo ohms. Okay, so this is equal 3.2 exponent 3 negative times 5 exponent 3 divided by 20 exponent 3 equals 800 microamps. So I have 800 microamps. amps. Okay, so this is my current I1. Next, I'm supposed to find I2. I2 is equal to 3 times I1. So this is equal 3 times 800 microamps. So this is equal 2.4 milliamps. Okay, so this is my current I2. Next, we are going to find the voltage across these two resistors. Okay, so let's check if I'm going to find voltage across resistor R1, that voltage is going to equal to this voltage. So VR1, okay, is equal I1 times R1. I1 we found is equal 800 microamps. So I have 800 microamps times R1, which is equal 20 kiloohms. Okay, so we have 800 exponent 6 negative times 20 exponent 3. This is equal 16 volts. 16 volts. VR2 is equal I2 times R2. So I2 is equal 2.4 milliamps, we found over here, times R2, which is equal 6.67 kiloohms. So I have 6.67 kiloohms. This is equal 2.4 exponent 3 negative times 6.67 exponent 3. This is equal 16 volts. 16 volts. So it means that our currents are correct, okay, and the value of resistor R2 is correct. Okay, so R total is also good. Okay, so now we can find the powers. P total is equal I total times the voltage across these two resistors. So this is, I'm going to call this just voltage. Let's put V12, means voltage across these two resistors. Okay, so this could be called voltage source, or let's say voltage V12. Okay, you have to understand that I'm talking about the voltage which concentrates across these two resistors, and because they are in parallel, so the voltages across them is they are the same. That's why I'm going to call this V12. So I total is equal 3.2 milliamps. This is my I total, which was given, times the voltage across either resistor. So I have 16 volts. This is my total power. Okay, this is going to be my total power. So 3.2 exponent 3 negative times 16 is equal 51.2 milliwatts. 51.2 milliwatts. So this is my total power. Next, I'm going to find the power at resistor R1. So I have P1 is equal I1 times V1. Okay, so I1 we found is equal 800 microamps times V1, which is equal 16 volts. Okay, so this is equal 800 exponent 6 negative times 16 equals 12.8 milliwatts. 12.8 milliwatts. Next, I'm supposed to find P2. P2 is equal I2 times V2. This is equal I2 2.4 milliamps times 16 volts equals 2.4 exponent 3 negative times 16 equals 38.4 milliwatts. Okay, now we are going to find the power in a little bit different way. You have to keep in mind that total power in the circuit is the sum of all these two powers. So I have P1 plus P2. P1 is equal 12.8 milliwatts plus 38.4 milliwatts. So I have 12.8 exponent 3 negative plus 38.4 exponent 3 negative. This is equal 51.2 milliwatts. 51.2 milliwatts. As you can see, okay, this value, which we obtain using different formula and different technique, is equal to this value, which we got by adding the powers at each resistor. Okay, so if they are the same, it means that everything, whatever we did, is correct, and all these answers are our solutions.